Good morning to all. Today we are dealing with the chapter shear force and bending moment diagram. So far in chapter first we have dealt with direct force which produce tensile or compressive stresses and have also learned about shear force which produce shear stresses. In this chapter we would study about transverse load which act perpendicular to the beam axis and produce both bending and shear stresses in any beam section taken across the beam. The intensity of bending stress or shear stress so produced in the beam section subjected to transfer load is directly proportional to the bending moment and shear force at the section. Basically, we see one by one. Now, content of flow, introduction, types of beams, and support condition, definition, sign convention, how to draw SFD BMD for standard cases, relation between shear force, bending moment, and load, and some example. Now, introduction. Now, here I am giving one beam which is simply supported, and that beam carries a two kind of load. It is a perpendicular to the longitudinal axis of the beam. One is the constant load and another is the distributed load. And now we have to analyze what effect due to the this kind of loading on the beam, and that effect we have to represent in the graphical form. Now, types of beam. I know you know about the types of beam, just I revise the things. Simply supported beam means either the end is pin or roller. So in simply supported beam, here one end is pin end and another end is roller end. Now in a fixed beam, the one end is a fix and another end is free. And fix on fixed beam there is three unknowns: rotation, horizontal, and vertical reaction. Now overhanging beam. Here the single span overhang beam or double span overhang beam is also there, but here I am just mentioning only a single span overhang beam. Overhang means one end of the beam is means extended from the one of the support. If you have to see the from the roller support, the beam will be extended somehow. Now continuous beam is there. Continuous beam means when the span of the beam is more than one, that beam is called as a continuous beam. Okay. Mm, Now, what is mean by determinate beam? Because you have to identify which beam is determinate and indeterminate. Basically, it is not needed for this subject, but it you have to know this uh, terminology. The force and movements of a reaction at a support can be determined by using the three equilibrium equation of statics. We can say a condition of equilibrium: summation of fx equal to 0, summation of fy equal to 0, and summation of movement equal to 0. Up till now, the all the beam, you have to see this all beam we can analyze by using your the static condition of equilibrium alone, because there is only three unknowns and that three unknowns can be solved by using the three equilibrium equation. Now in determinate beam, the force and movement of a reaction at a support are more than the number of equilibrium equation of statics. The extra reaction are called redundant and represent the amount of degree of indeterminacy. Now I just explain here over. Suppose in your simply supported beam, one is end is hinge and we can place another end is also hinge. Okay, and I provide the inclined load over there. In that condition, might be that beam is the four unknown reaction, and that four unknown reaction cannot be possible to solve by using the three condition of equilibrium. So in that case 4 minus 3 is 1, so the structure is redundant by using the degree of 1, so that is called as indeterminate beam. Okay.